We're now going to solve an index equation. If you take a look here at part A, the reason this is an index equation is because the unknown is the power. Also in part B, the unknown in the equation is the power. Now, in order to find what the power is, what we do is rewrite all the numbers in the equation as an indice with the same base. So you'll notice over here we have an indice with a base of 5. Can we rewrite the other side as an indice with a base of 5? Well, you can, because 25 is the same as 5 to the power of 2, because 5 multiplied by itself gives 25. So what you do is rewrite all the numbers in the equation so that they have exactly the same base. So we're rewriting 25 as 5 to the power of 2. Now, once you get to the stage where you have the same base on each side of the equal sign, and there's only one base on each side of the equal sign, then all you do is just equate the powers. So see the way we've only got 1 5 on each side? That means the powers have to be the same. So therefore, x must equal 2. Okay. Let's do the same in part B. It's a little bit harder. So it's an index equation because the unknown is the power. In order to solve it, we want to rewrite all the numbers that are in the equation so that they have the same base. You'll note that we've got a base over on this side of 4. Can we rewrite 1 and 16 with a base of 4? We actually can. We can write 1 as 4 to the power of 0, because anything to the power of 0 gives you 1. So we can write it here as 4 to the power of 0. And that's all over. We can rewrite 16 as 4 to the power of 2. Because 4 to the power of 2 means 4 multiplied by itself, which gives you 16. And then that's equal to 4 to the power of n. Now, we can only work out what n is once there's only one base in each side of the equal sign. The problem is there's 2 bases in this side. So what we're going to have to do is use indices rules to simplify. You all know that that is the same as saying 4 to the power of 0 divided by 4 to the power of 2. 4 to the power of 0 over 4 to the power of 2 is the same as 4 to the power of 0 divided by 4 to the power of 2. Now, when you divide two indices with the same base, you subtract their powers. So it's going to become 4 to the power of 0 minus 2, which is just 4 to the power minus 2. So that's using indices rule 2. So we're going to be left with 4 to the power of n is equal to 4 to the power minus 2. Now there's only one base in each side and they're exactly the same, so now we just equate the powers. So therefore n is just equal to minus 2. Okay. Part C, we have 64 to the power of x is equal to 16. Now, it's much harder, this one. The base over here is 64. Is it possible to rewrite 16 as a base of 64? No. It's very difficult to write 16 as a base of 64. So, can we think of a smaller number? Can we think of a number that we can write 64 and 16 in terms of? Like, for example, 16 you can write as 4 to the power of 2. Can we rewrite 64 as 4 to the power of something? Well, you actually can. You can write 64 as 4 to the power of 3, because 4 4s are 16 times another 4 is 64. So you can actually write 64 as 4 to the power of 3. Now I'm going to put brackets around the 4 to the power of 3 because there's an outer power here of x. Copy down equals. And we can write 16 as 4 to the power of 2. So when it's not possible to rewrite one number in terms of the base of the other one, you have to think of a smaller number. So you have to think, can I think of a smaller number that I can rewrite 64 in terms of and 16 in terms of? And you can. We can write 64 as an indice with a base of 4, 4 to the power 3. We can rewrite 16 as an indice with a base 4, 4 to the power 2. So the next thing is we have to deal with this inner and outer power. Now that's indices rule 3. If there's an inner and an outer power, you multiply them. So that's going to give us 4 to the power 3x. And then that's equal to 4 to the power 2. Now that we've only got one base on each side and they're exactly the same, now we can equate the powers. So therefore, 3x must equal 2. But we've a wee bit more work to do this time. We need to divide both sides by the coefficient of x. So we're going to get 3x over 3 is equal to 2 over 3. And then do our cancelling. 3's cancel. And we're left with x equals 2/3. So that's our answer for part C.